Okay, the first row, quadrant of alpha over 2. If I'm in quadrant 1, I'm between 0 and 90 degrees, right? What's half of that? 0 to 45? So I'm still in quadrant 1, correct? So the first row, the first answer is 1. You agree? All right. What if I'm in quadrant 2? Am I between 90 and 180? What's half of that? 45 to 90? What quadrant is that? 1. Okay. Next one. If I'm in quadrant 3, isn't that 180 to 270? What's half of that? And what quadrant is 90 to 135 in? 2. Does that make sense what we're doing? Oh, you should just be writing the quadrant. 1, 1, 2 is what we've done so far. That's all we're looking for is the quadrant. Now, what about quadrant 4? What's quadrant 4? Is it 270 to 360? What's half of that? 135 to 180?
Yeah.
What quadrant is 135 to 180? 2? So right now you should have in that first row 1, 1, 2, 2. Is that what you have? Did that make sense what we did? Okay, now what does it ask for? It asks for the sine of alpha. Do you know what it is in quadrant 1? Positive. What is it in quadrant 2? Positive. You should know what sign of whether it's positive or negative for sine of alpha, right? What is it in quadrant 3? Negative. And 4? Negative. That's all it asks for. The hardest part on this is figuring out what they were asking for, wasn't it?
Yes.
Okay, now, this one might be a little trick. The sign, whether it's positive or negative, of tangent of alpha over 2. All right. You have to go back to your first row. Okay? Your first row, what quadrant are we in? 1. What? Because that's alpha over 2, isn't it? So in quadrant 1, what is tangent? Positive. Okay? The next column, what is the quadrant for alpha over 2? 1. So is tangent still positive? All right? Then the third one, now what quadrant am I in? 2. Is tangent positive or negative in quadrant 2? Negative. And what's the last one going to be? Negative. Okay? That's all it was asking. Just to kind of make you think where you are on the quadrant. Identities. You all know the rules of identities. What are the rules? You can change one side but not the other. That is exactly right. What's your last row in the identities? You have to state that they're equal, right? So you got that? So can we work a hard one? Is that all right with you? I don't know that this is that hard, really. I'm just joking. See how much you remember. if I tell you cosine to the fourth power of x minus sine to the fourth power of x equals cosine 2x. I'm going to work on the left. Is that all right with you? Now, what were our rules when we worked identities? We get a common denominator. We can change the sign and cosine. We can FOIL. We can factor. Anything look like maybe it's a possibility?
Well, isn't 2x the half angle?
It's a double angle.
Or a double angle?
It is. But there's so much less over there that it worries me. What are you thinking, Caden?
So could you change sine to the fourth of x to this would be 1 minus cosine?
What about
I
square?
could.
The square.
Could.
Square.
Hadn't thought about that. That might work.
You could probably.
I have a question for you, though. And I think your way would work. I think it's just longer. And you know what? If you all figure it out, sometimes that's what you end up doing. It's what I end up doing sometimes. But is this cosine to the fourth minus sine to the fourth the difference of two squares?
That's the thing I was talking about. I couldn't remember.
You couldn't come up with the words.
I was saying squares.
So would this factor into this? Do you agree with that? And I kind of like Caden's suggestion because I think we would have got there eventually. Now what?
Do it again.
I can do it again. Can I do anything else? What?
Use the. You can change the sine squared x to cosine.
Okay, tell me the possibilities for cosine of 2x. Tell me the possibilities.
Oh, isn't it?
Have you learned them yet? Test is Friday.
Cosine squared x minus sine squared x 2 cosine squared x minus 1 minus 2 sine squared x.
Is cosine squared minus sine squared? Do we have a cosine squared minus sine squared?
Yeah.
So I have something I need.
So you need to get rid of the cosines.
I need to get rid of this. Any idea how? Huh? And so what is that equal to? Isn't this just 1? So really all I have is cosine squared x minus sine squared x. Don't I? What is cosine squared minus sine squared?
Cosine 2x.
Cosine. So does cosine 2x equal cosine 2x? If you guys don't have these memorized, you didn't see that this was 1, did you? What? Oh, I thought you had a question.
No.
So see why you have to learn these? Did you learn them and forget them? Why did you do that? We should do another one.
Actually,
I'm trying to figure out which one would be hardest. And notice what I did with my last step, and I keep saying that because I don't want to have to take off on your test because you didn't write that. 2 tan of x over 2 minus secant squared x squared equals tan 2x. Can I work left?
Yep.
Look at tan 2x. Are you looking at what tan 2x is equal to? What? How close am I?
Never
You just have to get the bottom.
I just have to get the bottom.
Can you just flip the secant to tan?
You change the secant squared x to 1 plus tan squared x.
Do y'all agree?
Yep.
Did you think about that? That you want to get rid of secant squared x?
I mean, I was getting to that part, yeah. I don't get it, but
2 tan x. What'd you say secant squared was?
1 plus tan squared x.
1 plus tan squared x. So do I have 2 tan of x over 2 minus 1 minus tan squared x? Right? So I have 2 tan of x over 1 minus tan squared x.
Tan positive on the bottom.
But don't I have to distribute my negative?
Yes. You do.
Is this what I want?
Yes.
So what's my next step?
It is. I thought it was positive that you wanted to place it down.
Like,
you have to put an equal.
Tan 2x equals tan 2x. Let's do a half angle. We ought to do a half angle, shouldn't we? Okay, sine squared theta over 2 equals cosecant theta minus cotangent theta over 2 cosecant theta.
I think we want to work the right side.
I agree,
Okay.
because I don't like to take things to cosecant and secant and cotangent, because I know sine and cosine better. So on the right, so what do you think I should do? On the right,
Change things to sine and cosine.
sine and cosine. Now, I'm assuming you all know how to do that without looking at it. Is that a good assumption? So I have 1 over sine theta minus cosine theta over sine theta over 2 over sine theta. Right?
Yep.
So you get
Just
1
cancel
minus
the sine.
cosine theta over 2. That doesn't sound right.
It's right.
It is right.
How close am I to what I need?
Aren't you like right there?
Isn't that
That's the answer, right?
That's the answer, right?
square that's not going to be irrational.
Oh, I see what you're saying. That it got rid of the square root sign. So are we good?
You have to put equal.
I have to put it equal. So that one wasn't too hard, was it?
No.
So are you good, or do you need one more?
Wait. So, okay, I have a question.
Uh-huh.
So since the thing is sine squared theta over 2, do you have to get rid of the sine squared on the left side?
I can only change one side.
No, but if the formula is sine of alpha over 2,
It doesn't matter. Well, I substituted in the right side. So for this, I substituted this in. Because it's the same thing. One more?
Sure.
Tan x over 2 plus cotangent x over 2 equals 2 cosecant x. I want to work the left. Is that all right with you?
yes. And I feel like for the formula, I feel like we should use the 1 minus cosine A over sine alpha.
Why?
Because
Sign's on the bottom.
Because sine's on bottom. That's what I wanted you to say. Because sine's on bottom. And don't I need sine on bottom? Does that make sense to you? So you're telling me this is 1 minus cosine x over, not 2, it's over sine of x, isn't it? Plus,
How did you get that?
off the peak sheet?
Oh, we can choose multiple. Okay,
Yes.
got it.
All right, now, I'm going to ask you a question. Is cotangent the reciprocal of tangent? Right? So to get what cotangent is, all I'm going to do is flip over tangent, right? So if I flip over tangent, do I want one that has sine on top?
But if you put sine on top, then won't sines cancel?
No, it's the reciprocal.
No, because I'm flipping it over.
Yeah.
See, I'm taking the reciprocal. So is it cotangent of x over 2 going to be 1 plus cosine of x over sine of x?
I thought you were taking the reciprocal of tangent.
No, reciprocal of cotangent. This is 1 over tangent, isn't it? Which is the reciprocal, which means I want a reciprocal identity. One of those identities, I'm going to use the reciprocal of it. Because cotangent and tangent are reciprocals. Does that make sense? So that's why I just flipped that one over.
But you just, are you looking at your beat sheet? Because we picked a different identity.
Yeah.
I don't know if you want to. I don't know what it is.
You might be right. That might be what it is. But now,
You can just cancel the choice.
Well, like, I know the identity that you're doing, but why did you choose a different one?
so sign would be in the bottom when I finished. So now I have a common denominator. You okay with that? So what do I have on top?
2
Over
sine.
sine x? What is that? 2 cosecant x equals 2 cosecant x? Does that make sense?